Um, okay, so the Sphere project, if you look at the project description, everybody, this is why I keep saying you have to read carefully and do whatever it asks you to do. But some of you seems not to have read the thing completely. I would say, if you look at this, okay, must have two constructors. One accepts nothing and the other another overloaded constructor that accepts parameters. Must have access and mutator methods for each instance variable and the toString method. Besides the other methods required by the project. For Sphere, the other methods are surface and the surface area and the volume. Must test all the two constructors, the accessors and mutators for each variable and the other methods, if there is any, explicitly in the driver class's main method with at least two objects. So that is my requirements. And it seems some of you did not read this thoroughly, or you didn't do it. So let's look at, this is Daniel's. And this is the Sphere class. And this is very good, right? And this is all correct. And he declared the pi as a private, but I would say private static. Oh, maybe if we do it, we cannot, not static. That's not what I meant. Okay. What I meant is final, right? If you make it final, no one can change it. So, okay, this is correct. This is the constructor that accepts a parameter. So this is correct. And get parameter, set parameter, that's all correct. Calculate the volume and calculate the surface area and the toString method. Okay, this is the diameter. Since this diameter, this class, remember I told you your toString method is to construct a string that returns all instance variables in a formatted way if you want to, right? So there is only one instance variable. So that's the toString method. This is the string concatenated and he is returning it directly. So this is correct, the implementation. However, Daniel, if you look at my comment, I said you must have another constructor, right? Which is the empty constructor. That's the problem. So I took 5 points off for that. But let's look at the multi-sphere. And this is good. Obviously, Daniel, you watched the video and you put this header in the driver class, which is correct. Some of you, very few of you put it in the sphere class. Always put your header in the driver class where the main method is. Why? Because that is the entry point of your project. Okay, so always put it here. And so Daniel did it the more complicated way. He read from the user, okay, read from the user and used those diameters to construct those spheres, sphere 1, 2, 3. Okay, so he read them and construct them. Let me get this off. And then he tested the get parameter for 3 objects. I said 2, but he did even more, 3. So he tested the get parameter. And then he tested the surface area, right? That is the one you need to test. That's not the mutator or accessor, but it's the other methods you must test. And then he tested the set diameter, okay? And then he tested the get again. And then he tested the volume, okay? And then he tested, thank you, you wrote, thank you. So this is very good. Where is the, oh, toString, okay, toString. And remember, Daniel, you don't have to test the toString this way. You can just do it this way, everybody, right? As a lot of you did it this way, yes. So that's what I meant when I say you test each and every instance variable. And the mutators and accessors, you have to test all of them. Okay, so this is the correct one. Testing is very good. I'm not going to run because I have to enter values. So any questions about this, everybody? Okay, the only thing that's not correct, that's not done, is he didn't do the empty parameter constructor. Okay, all others are very good with comments, correctly formatted. One or two of you have something like this. Okay, that's, oh, you see, I cannot even do it. So notice the formatting. This is the body of the main method. So it has to be indented. That's called self-documentation. And I like this formatting and the white space to separate the segment, which is very easy to read and you know what it is doing, right? So this is very good with comments and header and everything. So great work here. That's the only thing that's lacking. Okay, now let's look at Aaron's. I'm just going to close it. Did I change things? Okay, let's look at Aaron's. Aaron, we have 2 or 3 students who did the but the orange is the sphere. So I'm going to look at this one. Okay. Once again, this is because most students did this one. Okay. So sphere, double parameter, and this is the empty constructor. That means you don't accept anything, but you still have to initialize your instance variable. Remember, the purpose of a constructor is to initialize all instance variables. So this is that. And this is the constructor with input data, with a parameter. So that's what is lacking in a lot of your work, everybody. Okay, the 2 constructors. And then set parameter. Here it's rounding it and divide it. And get parameter volume, surface area, toString. And in this toString method, Aaron put the volume and surface area there. That's okay. That's okay. You don't have to, but that's great. That means once I know this, once I have this sphere, I know the diameter, I know the volume, I know the surface area. Those are descriptions, but you don't have to. You just need the diameter. Okay, so this is the main thing is here, right? The 2 constructors. Okay. If you didn't understand what I meant, now you should see and you understand it. Let's look at the multi-sphere. This is an extra credit work with extra credit. So yes, if you did the extra credit, Jesus, I told you, you have to say yes. Otherwise, I'm not looking for it, right? So extra credit, yes. And this is correct. The header is within this driver class. And this is the extra credit where you create an array, which we haven't learned. That's why it's extra if you want to go ahead and study. And then you initialize the sphere. But mainly, if you just don't create the array, you just say sphere 1, sphere 2, and then you will just say, and if you look at this, this is very similar to Python's list, right? So you can just say sphere 1, or whatever reference variable you have, new sphere, everybody. This is where you call the empty constructor right here. So when you do that, your sphere has a diameter of 0, right? Okay, and these all have those. So he is testing the empty constructor, he is testing the other constructor. And then he is printing it out using the get diameter. And for the first one, it would be 0. And for this one, this is what? This is increment the diameter. No, what are you doing? Increment b plus 1 sphere. Oh, okay. So he is saying sphere 1 is equal to sphere 1 plus the sphere itself. This is the toString method, really. Okay, in the array. And so get diameter, volume, you test them explicitly in the driver, even though he did this he called the methods in the toString method of the sphere class, you still need to test it explicitly. That's why I'm saying explicitly in the driver class. So he's testing surface area, volume, and then get diameter and set. Where is the set? Let's see. Where is the set, Aaron? Oh, set here. Okay, set diameter, right? So he tested all of them and the toString. So that's this project. Any questions, everybody? Okay, if you don't have any questions, we continue with chapter 7. Okay. Let's continue with chapter 7. I'm going to stop. This is really pretty much done because we discussed this already. I think we discussed this last time. And I gave you this example. For example, your account, suppose name, account number, and balance, they are the instance variables. Okay, yeah, they are the instance variables for this account class, but your name, but your parameter names are the same. So how do you differentiate them? You use this to differentiate them. So let me ask you, what does this reference? Which one? About the two names, with the two names, which one is the instance variable? Which one is the parameter value? Everybody? Joanne, I'm going to ask you, which one is the instance variable here? For example, this, which name? Is the instance variable?
It would, well, the instance variable, this dot name.
Yes,
correct?
That's very good. Yes, this is the instance variable. This means the current running object. Okay, whichever object is running, it's saying its name. So this references the current object, and this dot name references the instance variable of this class, while this one comes from the parameter. Okay, you use this to differentiate them because they have exactly the same. You are using the same parameter name as the instance variable name, so you differentiate them. This is one of the usage. And here I'm giving you another example. Because this has the same name, okay, they are the same, so you use this to differentiate them. But this is number, so you don't need, because they are different. And this is amount, they are different, so you don't need this. Okay, that's how you use this to differentiate two names with the same name, two attributes with the same name, to differentiate between the instance variable and the parameter value, okay, the parameter name. Another way to use this, which we will discuss in chapter 9, is inheritance. When you use this to reference the current object, etc. Okay, we will discuss that later. Now let's talk about interfaces. Okay. Before we go on, this is brand new concept. Any questions, everybody, about these? Let me ask you this question then. Let me pause. I'm not going to put this review in. Okay. I will let you read because this is whatever I say, it's really here. And then I'm going to ask you questions. Okay, let me ask you, how do you, okay, here is my question. Is abstract a keyword? Yes or no? Okay, abstract is a keyword. Okay, very good. And an interface is a collection here. It's a collection of abstract methods and constants. Let's look at an example. this is easier to understand. Okay, so interface is the keyword, right? Instead of class, you use interface. And this is the interface name. Interface is a collection of abstract methods and constants. So all these methods are abstract, but you do not have to have the abstract keyword here because by default, all methods in an interface are abstract. That's why you don't have to put abstract here. Okay, you don't have to. So, but it is already abstract. Okay, so the thing to remember for interface is that it doesn't have a body. So you only have the semicolon to end. This is basically the method header without the body and end it with semicolon. You cannot even do this. Okay, that would be wrong. You cannot do this. That would be wrong. So make sure you remember that. This definitely will be on your test. Abstract method is method header ended with a semicolon. Okay, if you look at these. Any questions? Okay. An interface cannot be instantiated. What does that mean, everybody? What does instantiate mean? Do you remember what this means? It means you cannot create an object from an interface. Okay, instantiate means create an object, instantiate an instance. So you cannot create an object from an interface. Okay, methods in the interface have public visibility by default. So these, even if you don't put public there, they are public. Okay. But I would recommend everybody always put the visibility modifier there, whether it's public, protected, or private. Make sure you put them there. Okay, protected, we may not have learned that. I don't remember if I mentioned that. Okay, a class formally implements an interface by stating so in the class header, and we will look at an example. And you also, if you implement an interface, you have to provide implementations for every abstract method in the interface. If you look at this interface, they don't have a body. Remember, they do not have a body. So you cannot call this method because there is no implementation. It doesn't do anything, right? So if you say, I'm going to implement this interface, you are responsible to provide the body. When we say providing implementation or definition, we mean you have to provide the body. If a class declares that it implements an interface, it must define all methods in the interface, not just one, not just two, but all methods. So if you say, I'm going to implement doable, this interface, you have to provide the body for all these methods, okay? So let's look at this example. This is public class can do, implements, that's the keyword, implements doable, okay? And then you have to define the body, whatever you do, that's the code there, whatever you want to do, right? The code. So this is the body, everybody. Even the, okay, just let's say we don't provide implementation, there is nothing in this, it still works because this is the body. Remember the curly braces, that is the body of the method, right? But usually you, of course, you actually do something there. So this is the implementation. Okay, questions? In addition to, or instead of abstract methods, an interface can contain constants. That means, for example, your math.py, right? Math is not an interface, so I wouldn't say that's a constant. Well, there are some other constants. Let's when we encounter them, we will talk about them. But your interface can contain constants, which is a final variable also. Okay. When a class implements an interface, it gains access to all its constants. Okay. A class that implements an interface can implement other methods as well. So here is an example. I'm giving myself a note in Eclipse. So we will look at it in Eclipse. But here is the example, right? Okay, so let's look at the Eclipse. I import it into Eclipse so we can look at it. Okay, that's the mini quiz, right? That is the mini quiz. Okay, so here it is. Okay, so here is the interface. Notice that here it has J, and it has that symbol. That means it's an interface. Okay, everybody, this is the interface, right? We didn't see this. This is brand new. Okay, this interface has two methods. Are they abstract, everybody?
Yes.
Yes, by default, all methods in the interface, in an interface, are abstract. So this interface name is complexity, and it has two methods. That means if you decide to implement complexity, you must implement these two methods. So let's look at question. Okay, this is a class that implemented complexity. Okay, so public class question. Now let me see if I can use this. Yeah. Okay, public class question implements complexity, right? That's the keyword. That's the interface. And so those are the three instance variables for question, okay? And then here is the constructor. And okay, here, set complexity and get complexity. These are the two methods in the complexity interface. So you are implementing them, right? So that's the implementation. And then remember, it says you can have other methods as well. So the other methods are get question, get answer, and also answer correct. So this is testing if the answer is correct. If you look at this method, answer correct, it returns a Boolean, it returns true or false. Okay, give me a candidate answer, and I will see if this answer is equal to that candidate answer, right? The current answer for this question, are they equal? If they are, you return. If they are not, you return. If they are equal, this will return true, and you will return true. If they are not equal, this will return false, and you're returning that result false. So let me ask you, why do we use dot equals instead of using the double equal sign? Why?
Because you're using a string.
Yes, very good, because we are using strings. For strings, when you compare them, you cannot use double equal sign. You can only use dot equals. Remember, double equal sign tests the addresses. Equals tests the actual values of the instance variables. Okay, and we discussed that in Python even, right? Okay, toString. So this is the class. Those are the two methods that are there from the complexity interface. Now let's look at mini quiz. Mini quiz, okay. So you declare you have two questions, and then you ask the user, you instantiate those two questions, and you set the complexity to 4 and set the complexity to 10. So this is the question, and this is the answer. If you look at your question class, right? Question, that's the question, and the answer, that is the answer. Okay, that's how it's done. So here, this is the question, the first string, the second string is the answer. And then you set the complexity. Okay. Okay. And also look at question, just to review. Remember, your constructor is to initialize all instance variables. Even though there is not a value for complexity in your parameter list, you still have to give it a value by default so that every question has a complexity level. So in this case, you are giving it a 1, right? You can decide, you can say 0, you can say 1, you can say 10, but that's the default complexity level. Okay. And so for these two objects, their complexity level are set differently, right? Here, you set it to 10 and set it to 4 for the first one. Okay, and then, okay, we print out get question and get complexity and test if it is possible and do the same thing for the second one. Let's run it. Okay. Okay, so that is how this works. Any questions? You might not quite know why we need to do this yet. Okay. But do you understand this? Basically, look at question. It implements complexity, and it has to implement those two methods. Okay, now I give you another. I just wrote this game, for example. Okay. My game also implements complexity. What does that mean? That means it must implement those two methods, right? Get complexity and set complexity. So what this means, if multiple classes implement the same interface, that means they are the same. You will treat them as the same object. For example, once again, you might not understand this, but for those students who are curious, who ask, why do we need an interface? What's the purpose of an interface? Here is the purpose. You can actually, okay, create, I'm going to do this. You can actually create a game. Game 1, oops, this is my notes. Game 1, game 2, and you can create an array, just like in Python. You create an array, a Python is called list. Okay, you create this, and then you set, say they all belong to complexity. Okay, now let's look at this. So you put them into the array. Now, basically what this is doing is an array or a list, their elements must be the same. They cannot have different elements. But here we are putting different typed elements in it, question and game. We are putting them in one array. And that's not possible, but now it is possible because both game and question implement the complexity interface. So they are basically also complexity. And you don't quite understand this. So I'm just trying to explain why we use interface. You will understand this much better in class 3, okay? Any questions, everybody? Yes, it is like a structure. If you say you are this, you implement this, you must follow that structure. You must do all the things listed out in that, you're right, in that outline, right? You must follow those rules. So if you say, I'm going to implement complexity, then you must implement those two methods, because those methods are outlined in that interface. Yes, that's correct. Any other questions? Several times, and look at the examples I gave you. Okay. Okay, so a class can implement multiple interfaces separated with a comma. The interfaces are listed in the implements clause. The class must implement all methods in all interfaces. Okay, so here, class many things implements one interface, two interfaces. So then you have to implement all the methods listed in interface 1 and interface 2. Java can, oh, we haven't discussed inheritance. Okay, I'm going to pass that. That comment, I'm not going to make that comment. So you can implement multiple interfaces, okay? The Java API contains many helpful interfaces, and one of them is called comparable. The comparable interface contains one abstract method called compareTo, which is used to compare two objects. Okay, so when you want to compare two objects, you cannot use the double equal sign. You cannot use the less than or greater than sign. You have to use equals, which compare if the two objects are the same. You have to also use compareTo to decide if one object comes before or after the other. So there is no other way. For example, if you have object 1 and 2, okay, you cannot say if object 1 is greater than object 2. You cannot do that. This is not correct. You cannot do if object 1 is double equal sign object 2. You cannot do that. That's wrong. For equal, you already learned we have to use the equals method. For which one comes first, we use compareTo. Okay. So the string class implements comparable, giving us the ability to put strings in lexicographic order. Okay. So this is how you use compareTo. Object 1 dot compareTo object 2. So this compareTo method returns an int. It returns an int, a number. If this object is greater than this one, this will return a positive number. If this object 1, is less than object 2, it will return a negative number. Okay, so that's why here you look at this. If this returns a negative number, that means it's less than 0. Then you will say object 1 is less than object 2. Okay, that's how this is used, the compareTo method. The value returned from compareTo should be negative if object 1 is less than object 2, 0 if they are equal, and positive if this is greater than this. Okay, so if it returns, if it is 0, then that means the two are equal. Let's look at this example. That's what I'm trying to do here. I'm going to just delete this. Okay, so if you look at my question, I am going to implement, I commented this out, right? I am going to implement comparable also. Okay, so now my question implements both complexity and comparable. You have to put this here. This is something you will understand in class 3. If you go ahead and take class 3, you will understand that. Basically, this is saying this question can only be compared with a question object. Okay, that's what that means. This class, an object of this question class, can only be compared with a question object. Okay, so see what the problem is. The type question must implement the inherited abstract method compareTo. So because we are implementing comparable, you must also implement the compareTo method. So comparable is an interface. It has one method, compareTo. If question implements both interfaces here, okay, then you must implement all methods in each interface. In my implementation, obviously, I did not implement the compareTo method, right? Okay, so that's that. And all others are the same. These are the two methods in the complexity interface. Now, Here is my implementation of the compare to methods. If I take this off, you will see, okay, the error is gone, right? Because I implemented the compare to methods. Let's see how this works, everybody. Okay, how do you compare two objects? You compare two objects really depends on how do you compare them, really depends on what your intent is. If you are comparing two people, for example, how do you compare two people? It's difficult. You can compare two people and see if their names are the same. If they are the same, you define, you say, okay, if they have the same name, they are the same. Or you can say if they have the same name and also have the same age, they are the same. Or you can say if they have the same name, the same age, and the same address, they are the same. So you decide what is the same, what is equality. It's the programmer who decides in a reasonable way. For me, when I compare two questions, okay, for this project, I'm just comparing their complexity level. If they have the same complexity level, that means they are the same. If they then one is less than the other is greater than this one or something. So that's how I will compare them. So here is the implementation, everybody. Okay, look at this. Let's understand this. Public int compare to, that is the method in the comparable interface. When you compare with this current object, which is a question, you must give me a question, right? Give me a question. So that's the question reference variable, the parameter. If this, remember, this references the current object. If its complexity level is less than Q, the given question, dot get complexity. Remember, get complexity returns the complexity of the other object you want to compare with, right? So if this complexity level is less than Q dot get complexity, return -1. That means this is less than, the current object is less than the given object, the compared object. Else, if it is greater than the one from the question, then you return +1. Else, return 0. That means they are the same. Look at this implementation. See if you can understand it. Okay. And now let's go to the mini quiz. Okay. I am going to just comment this out. Okay. We don't need that. I realize we haven't discussed array yet. And okay, so here, this is Asa, this is your question. So let's look at this. Okay, if Q1, what is Q1? Q1 its complexity level is 4, right? We set it. If Q1 compared to Q2, so we are calling the compare to method of question, right? We are calling this method here. Okay, so if Q1 dot compare to Q2, let's look at Q2. Q2's complexity level is 10. Okay, so if it's less than 0, what does that mean? Remember, if Q1 is less, if its complexity level is less than Q2's complexity level, it will return a negative number. Okay, so go to question. It will return a negative number, right? If it's less, it will return a negative number. So if that is a negative number, it's less than 0, that condition will be true. And it will say Q1 is less difficult. Else, Q2 is less difficult. Okay, let's run and see if our compare to method is correct. Okay, so if you look at this, Q1 is less difficult than Q2. And that is correct because Q1 is 4 and Q2 is 10. That means our thing is correct. Now let's set it both to 10. Okay, Q1 and Q2 both are 10. Now let's run. It shouldn't return anything. I should say, okay, let's say else. Okay, am I still recording? Yes, okay. Q2, if this is greater than 0, that means Q1's complexity level is greater than Q2's. Q2 is more difficult, right? It should be. Q2 is less difficult, right? Q2 is more difficult, or is less difficult, yes. Okay, else, they are the same. That means when they are equal. Okay, let's run. So we go to mini quiz and let's run. So now it should say they are the same, right? Okay. Because they have the same difficulty level. Okay, they are the same. So now let's run it one more time and let's make this 20. So now it should be Q1 is more difficult, right? Okay.
Just like Q2 is less difficult.
Okay, okay. So it means Q2 is less difficult. Yes, that means Q1 is more difficult. So, and you can see you test it and the compare to method is correct. And that is what that compare to method is, everybody. Do you kind of understand it?
Yeah, I guess I asked about the.
Okay.
Are you gonna start?
Yeah, go ahead.
Never mind. I was gonna ask if you're gonna start recording again.
Yeah, yes, I think I recorded. Yes. Okay. So I will let you read this. This is saying you could write a class that implements certain methods such as compare to without formally implementing the interface comparable. That's saying you don't have to say I'm implementing comparable. You don't have to say that, but formally declaring you are implementing comparable makes you a comparable object. You can use it in a certain way and the user can look at it and know immediately that you have a compare to method. So that's the benefits that you don't quite understand yet, but gradually, as I said, you will understand it completely in COSC 2436. That's the next class. Okay. Interfaces are a key aspect of object-oriented design. Okay. So now let's look at method design. That's the last subject of this chapter. Method design, okay. High-level design issues include identifying the classes and objects and assigning primary responsibilities. How do you do the first one? Everybody?
Nouns.
Nouns, look at the nouns, and they are potential. They are not all objects. And you have to look at whether you can break it into multiple pieces, further pieces of information, or it's already the smallest unit, right? Like atom or quark, you know, in physics. So you have to split it and see if you can break it into pieces of information. You break it into int, double, and the string and the boolean. If you can break it into those pieces of information, you have to. It will be a class. Okay. After establishing, it is important to address layers such as design of the key methods. And this is the responsibilities of the class. Those are the verbs. For some methods, careful planning is needed to make sure they contribute to an efficient and elegant system design. Okay. So method decomposition. This is saying, I will let you read this, but this is saying, if you are to accomplish a big task, you use the divide and conquer mechanism, right? Okay, this logical task is very big. What do? You break it further. For example, you say, okay, I'm going to write a program. This is a big logical task. But to write a program, what do you have to do? You have to know what I need to write about, how I will write it, and I will actually write the program, implement the program. I will have to test it, right? Those are the 4 basic tasks to write a program. And then for what to write, you have to break it into read the requirements, understand it, analyze it. You know, you break it step by step. So that's method decomposition. And here is an example. Let's look at an example that requires method decomposition, translating English into Big Pig Latin. Okay, Pig Latin is a language in which each word is modified by moving the initial sound of the word to the end and adding a. Words that begin with vowels have EA sound added to the end. Okay, so here is book, not vowel, so you just add, you move B to the end and add A. And this is not a vowel, you move it to the end and you add A. This is a vowel, so you add yay to it, right? This is a consonant cluster, you move it to the end and add A. Okay, that's the rule. So method decomposition, how do you achieve this? This is a big task. You want to translate English into Pig Latin. It's a big task. So we look at it. Translating a sentence can be decomposed into the process of translating each word. The process of translating a word can be separated into translating words that begin with vowels, begin with consonant blends, and begin with single consonants. So those are 3 logical tasks also. Okay, this is the method decomposition. You break it piece by piece until you can easily accomplish it with a single method, right? So, okay, this is the uses, everybody, right? Uses relationship, and plus sign means public, negative sign means private, okay? That's the UML. So now let's look at this program. I also have it here. Okay, now we are done with that. So I think I put it here. Pig Latin, yes, okay. So let's look at this translate. Let's look at this Pig Latin. This is the driver, okay? If you look at it, string, and create a scanner, and get a sentence from the user, read it, no punctuations because it cannot translate that. And then you simply call translate. This syntax, what does this syntax tell you about the translate method? Everybody?
That translate is static?
Yes, very good. Translate is a static method, okay? You use the class name and the method name and translate whatever the user entered. And then that's it. Look at your driver. That's it. You ask me to translate, here it is, right? You print it out and ask the user if they want to do it again. And you just redo it. So very, very simple, clear, and not stuffed, right? It's very well organized. You look at this program immediately, you know what it is doing. So all the detailed work are hidden behind this one method, translate. Let's go to Pig Latin and look at the translate method. Here is the translate method. Okay, it's also not long, right? It's a simple method. Look at it. Okay, give me the sentence. I'm going to translate it. First, make it all to lowercase so that case doesn't matter. And then everybody look at this, create a scanner. This time the scanner is not used for the keyboard. It's used for a string, okay? This means scanner has several constructors. One constructor accepts the system.in, which is the keyboard. It represents the keyboard. It also accepts string. So this is accepting a string. So this scanner will scan through whatever you passed to the user, whatever you pass to this method, the user input. Okay. So while scan has next, this is saying, does it have another token? A token, I think I explained this. A token is simply a cluster of characters. Okay, it stops when it encounters a space. So this is a token, this whole thing. This here is a token actually, because a token is a cluster of characters without space. So this is a token, and then this is a token. To the computer, to us, this doesn't make sense. You should not have the parentheses, but to the computer, this is a token, because that's the beginning and end of that cluster of characters. This is a token, this whole thing. Okay, that's what a token is. So it says, while scan dot has next. So it goes from the very first one and then to the next one. This is the iterator. It just iterates through the whole sentence. You don't have to worry about, you don't even have to use a for loop or whatever to increment to go to the next token. Just use this scanner to read through. When it reaches the end, it will say has next is false, so it will stop. Okay, so let's look at this. This is also very clear cut. Translate word. You know, you translate a sentence. How do you translate a sentence? You translate each word in it. How do you translate each word? You use a while loop, right? But how do you translate that word? And notice this is scan.next. It's using the scanner to read the next token. The first time is the first word, the second time the second, the third, the fourth. Okay, so it's reading the next one and the translate word. And all the detailed work is also behind this one method. And notice this is static. And this method is static also. Let's look at translate word. Okay, give me a word, I will translate it. And look at this, it's also very clear cut. Okay, if begin with vowel, give me the word, I will test and see if it begins with a vowel. This is a method, right? Begin with vowel, it's a method. If it begins with a vowel, I will add yay to it. Else, if it begins with a blend, okay, result will be the beginning with the third character, because a blend, a consonant cluster is two consonants, chair, CH, right? So, so beginning with the third word to the end, that's the first part. And then you get the first two characters, right? You move them after the word and then yay, add a to it. So this is begins with blend. And then else, this is just a regular this is just a regular word. So you will get everything beginning with the second character, right? Substring 1, beginning with the second character, leave the first one out, move the first one to the end, and then add a to it. So these are the 3 scenarios you are covering. And you are testing if it begins with vowel, if it begins with blend. The other one is the next scenario, so you don't have to worry about it. Okay, now let's see, begins with vowel. How do you test if it begins with vowel? Okay, you declare a string, these are the vowels, right? Okay, remember they are all in lowercase because in Pig Latin, oh no, here we moved it. We made it into lowercase, I remember somewhere. Yes, here. So it's all in lowercase already in translate. So here, okay, char letter, word dot char at 0, okay? So you're looking at the first character. So let's say item, okay? The first character is I, right? And you are trying to see if that letter, which is I, is in this string. So you are trying to find the index of I. Vowel, right? The index of vowel has A, E, I, O, U. And you are looking at the index of I, because I said you use mark, for example. Okay, not mark, item. Okay, so you are looking at the I's index. I's index is what? 0, 1, 2. It returns a 2. So here, this is returning a 2. And when you say 2 is not equal to -1, that's true. So you return true, right? You return true, that means it begins with a vowel. Let's do another one. Let's say mark, okay? So the first character is M. So your letter is M, right? And here you are looking for the index of M in this string. It's not here. If it's not here, this method index of returns a -1. So it returns a -1. That's the comparison. -1 is not equal to -1. That's not true. They are equal. So you return false. So it means it's not a vowel. Okay? That's how that method works. And here, so suppose your word is chair. Okay? Your word is chair. You're looking at the word chair. Does it start with BL? No. Does it start with BR? No. Does it start with this? You know, these are all connected with or, right? This one, BL or SC or BR or SH or CH. This expression gives you true. So it stops, short circuit, it stops, and it returns a true. That means it begins with a blend. That's how these methods work. Any questions, everybody? Okay, so if you look at this once again, translate, that's the public method that you use in your, as a client, you use that one method. You don't know how it does it. You just know, I give you a sentence, you will give me back the result, right? I'm going to print it out. So this is the method that's public. Well, behind the scene, behind this public static method, look at all the private methods. They are all static because they are used in the static method. So they are all static, everybody, right? But they are private because they are not useful to the client. The client doesn't have to use it. It can only see this one thing. So here, to translate a whole sentence, you need to translate each word. And that's what this is doing, translate the word. To translate a word, you need to see if it is a vowel, if it begins with a vowel, or if it begins with a blend. So that's that method. Okay, that's method decomposition. Any questions, everybody? So that I can enter a sentence, I sit in a high chair. Okay. So if you look at this, I is, okay, I will just let you look at that. That's a vowel, and you add yay to it. Sit, you move S after it, after add to the end, and add A to it. In, okay, in, it starts with vowel, so you add yay to it. It starts with A, so vowel, so you add yay to it. And high starts with I, H, which is a consonant. You move H to the end and add A to it. And chair, it's a consonant cluster. You move CH to the end and add A to it. So that's that, right? Oops. Does that work? That should work. That doesn't work because I entered 2 characters. Okay, so what was your question? What was your question, Asa?
So I was looking just like how it would build the like the compounds or like the blended words. If I was trying to think if there was any like easier way to at least implement it and have it do like determine if it's a blended word and transfer.
Recording. Okay, thank you. Okay, so we are done with this one, right? Okay. Okay. Now, objects as parameters. Objects can be used as parameters. You already saw that. You saw that in the rational number, then you remember subtract, divide, they all require a rational number. So that's an object. It's the parameter, right? So you know that. And also something you need to remember, this I remember it's on your test, okay? A copy of the actual parameter. The actual parameters are the value passed, and the formal parameters are in the method header. So let me just get that clear, explain that to you. This is called the formal parameter, okay? Because it's established the guidelines. This is the structure, the class. This is the formal parameter, okay? Now, if you go to pick Latin, this is the actual parameter. This is the variable with the value. So this is called the actual parameter. And this is called, where is it? This is the definition, everybody, right? And this is called the formal parameter here, okay? These are all actual parameters because you are using the actual value. This is the actual parameter. This is the formal parameter. When you define it, it's the formal parameter. Okay, in the method header. When you actually call it, that's the actual parameter. When an object is passed to a method, the actual parameter and the formal parameter become aliases of each other. Okay, let's look at method overloading. This is a very important subject. This is a very important concept. So let's look at this. Let's look at one more important method design issue, method overloading. This is the process of giving a single method name multiple definitions in a class. If a method is overloaded, the method name is not sufficient to determine which method is being called. The signature of each overloaded method must be unique. What is the signature? The signature includes the number, type, and order of the parameters. Okay, let's look at an example. So if you look at the example, okay, I cannot see up there because I have this. Okay, method overloading. Okay, the compiler determines which method is being invoked by analyzing the parameters. Okay, the parameters. It matches the actual parameters with the formal parameter list in number, type, and order. So look at this. This is the method definition, right? You're defining this method. This is the formal parameter. One formal parameter of int type. So when you actually call it, look at this is the actual call. This is the one parameter. This matches this. Data type, number, they all match. So it's calling this. Well, this is the overloaded try me method. This one differs from this one in the parameter list. This one accepts two parameters, one int, one float. And the return type, they are the same. Overloaded methods are distinguished by their signatures. Okay, so the signature is the parameter list. They are different. So here, when you do this one, this matches this. That's an int. And this actual parameter is a float. It matches this. So when you do this, the system will look at this method. No, it doesn't match. And then it looks at this method. Oh, yes, it matches. So it uses that method. Oops, no, that's not what I meant. Okay, okay. So when you use this method, when you call try me with one parameter, it will look at this one. Oh, it matches. It immediately uses this one. However, if you do something like this, okay, it will look at it. Oh, you have 3 parameters. It doesn't match this one. It doesn't match this one. No, it won't work. I don't have a definition that accepts 3 parameters. So this will not compile. Okay, that's called method overloading. Any questions, everybody? Okay, the print line method is already overloaded. Look at this. This is accepting a string. This is accepting an int. This is accepting a double. So that's the overloaded print line method. So when you do this, this is a string, right? It goes to this one. It matches this one. When you do this, this is an int. It matches this one, an int or a double. If total is an int, it will go to this one. If total is a double, it will go to this one. So that's method overloading. And remember, I showed you the constructor in chapter 4, the projects, we showed that. And also here, okay, look at this scanner. Look at this one. This constructor accepts a string, while this constructor accepts system.in. That's the keyboard. So this scanner constructor is overloaded. It has multiple versions. You can use it to create a keyboard reader scanner. You can use it to create a string scanner. So that's the overloaded version. Okay, that's keyboard, and this one is a string. Okay, that's the overloading there at work, right? The return type of the method is not part of the signature. Return type doesn't matter, everybody. Okay, you are only looking at the signature, which means overloaded methods cannot differ by their return type, but only by their signature. Constructors can be overloaded. Overloaded constructors provide multiple ways to initialize a new object, okay? And we have that. So let's look at these examples. Must have different number of formal parameters. Example, okay. This one accepts 2 int parameters. This one accepts int 3. So this is okay. They are overloaded correctly. That means the compiler knows which one you are calling. When you have 3 int, it will find the definition for that, right? If there is the same number of formal parameters, it must have at least one different type. So double average. The same number of parameters, 2, but then you must have one that's different. Okay, this one differs in number. This one, the same number, but this is different. The data type is different. That's okay. This one, you have the same data type, the same number, but the order is different. So int, double, and double int. That's okay. That's called what? That's called overloading. That's correct. Okay. Now let's look at this example. Public char grade, letter grade, int score. Public int, letter grade, int points. Do you think, I omitted the body. Okay, just look at these 2 headers. Are they correctly overloaded, everybody?
If it's looking for, just depending on the input, I think it is, because
It is, okay. Are they, okay, this is how you overload a method, everybody. Remember, the parameter list, that's the signature. It must be different. So look at the signature. Are they different?
Oh, the in and in, so it would not be, you wouldn't be able to, if it was like a char
Yes.
score
That's
and
different.
int points, then
Yes.
you can do that, but if it's in and in, then no.
No, this is, we are looking at data type. These are just placeholders. They don't count. They are just names.
Okay.
You can give it any name, but the system is looking at the data type. Okay, so this is the wrong overloading because you have exactly the same number, the same data type. So not correct. Even though the names are different, remember, these are just names. You can name it anything. Okay, so that doesn't count. What about this one? Are these correct?
They
Everybody?
are overloaded.
Yeah, Brian, what did you say?
I said they're overloaded. They have like the first one has only one int
Yeah.
value, and the second one has two.
Yes, yes. So this is correct. The signature, remember, when you look at overloading, when you look overload methods, you are looking at one thing, which is the signature, the parameter list. They have to be different in number or and type or and order. Okay, so this is two different parameter lists. So this is okay. What about this one?
That one's not the same, or that's not properly overloaded.
No, it's not. The reason is they have int, 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 int. Once again, I'm just illustrating to tell you this doesn't matter. The names, they don't matter. Okay, you're looking at the data type. So what about this one?
That is.
That one is because the order's not the same.
Yes, yes. Oh, this is a space. I put a space there. I thought three. Yes, the two parameters are the same type, but the order is different. So this is okay. Okay, that's how you look at overloaded methods. I have this. I put it in the. That's where it gave me the problem I was going to show you. So this one. I'm going to show you this one. Okay. Here. That's this one, but I have it here. So if you look at this, okay, class player, 3 private instance variables. That's the empty parameter list constructor. And this is the constructor that accepts those 3 parameters. This is called constructor overloading, right? You are overloading this constructor. So overloaded constructor, remember, what does it do, right? Overloaded constructors provide multiple ways to initialize a new object. So you can create a player, just a placeholder with nothing, no values. You know, I'm going to have a player on my team, but I don't know who yet. So you create that position. It's almost like a position, right? You create that position and no actual value. Here, you are creating a position as well as the actual object. You have all these information. So that provides a way, different ways to initialize object. That's what this is saying. Okay, that explains this, right? And then, okay, what did I want to do? Okay, here. So that's the player, void play and avoid play. Okay, let's look at player driver. So this is the empty parameter list. That's good. And this one accepts 3 parameters in that order: string, int, and string. And that's good, right? String, int, and string. String, int, and string in that order. That's correct. So that's that. And then now, player 3, new player. This one, I have string, string, and int. And this is not correct because we do not have a constructor that accepts a string, string, and int, right? So the order is extremely important. You have string and int and string, but not string, string, int. So that's why this does not compile. Okay, incorrect. And now let's call this player 1 play. That's good. Player 2 dot play. That's good. Why? Because we have 2 play method overloaded. Play that accepts nothing and play that accepts an int. So when you call it, that's good. right? But you cannot do this because you don't have a method that accepts 2 int parameters. You only have a method that accepts 1, right? So this one will not work. That's why. Okay, and then, oh, I gave you that example here. So this will not work because the compiler simply cannot find that method that accepts 2 parameters. It cannot find it, so it does not compile. Okay, that's that. Any questions, everybody? I
No.
have it. No? Okay. Oh, we are done. Okay, so we are done, everybody. I'm going to stop recording.